In this video, I'm going to solve an example on non-constant acceleration motion. So you make a small rocket ship which you launch vertically, and quickly after takeoff it reaches a speed of 15,000 kilometers per hour. How high does the rocket ship get above the Earth's surface? Don't take account of the air resistance. Let's say this is the surface of the ground and the radius of the Earth is r. The rocket ship is launched from here and the initial velocity is v0. It reaches a height here where the distance to the center of the Earth is let's say it's h. For solving this problem, we remember that v divided by dt is equal to a, which is equal to force divided by mass of the rocket ship. Now I'm going to multiply dy. Let's say this is my y direction. A dy divided by dy. So this is just a 1. But note that dy divided by dt is just v, dv, and I can take dy the other side, equals f divided by m dy. Now f is just minus g, Newton's gravitational constant, m, mass of the rocket ship, m, mass of the Earth, divided by, in this case, it's y square. So the origin of my y is here. So that's why f equal. So now, therefore, v dv equals minus g m dy divided by y square. So now I can integrate the two sides, v square divided by half from v0, which is here, to, so at this point v has to be 0. So it has to be 0 because it stops here. Equals minus g m, and an integrate of that is divided by y, and this becomes positive from, so the distance originally was r and now it is h. So therefore minus v0 square half is equal to g m 1 over h minus 1 over r. So now therefore minus v0 square divided by 2 gm plus 1 over r is equal to 1 over h. Therefore h is equal to 1 divided by 1 over r minus v0 square divided by 2 gm. So now we are interested in this distance from here to here, which is h minus r. So I'm interested in h minus r equal to something. Now let's say all these numbers can be found online, like r, radius of the Earth, is 6,371 kilometers. So 6,371 kilometers. So it's actually 1,000 meters times 1,000 meters. V0 is given in the equation. It's 15,000 kilometers per hour. So we need to convert it to SI units. So kilometers is again 1,000 meters, and Hours is 60 minutes times 60 seconds, so it's 3600, and it's meters per second now. G, Newton's gravitational constant, is 6.67 times 10 to negative 11 SI units. So when we are doing everything in SI units, then what we finally get is also in SI units. And mass of the Earth is 5.97 times 10 to 24. That means 24 zeros here. Kilograms. So it's also SI units. Now all I need is to insert all these into a calculator. So here I have, let's say, a Python Jupyter notebook. So it's basically a calculator. I have defined all these numbers here. So R is that, and these are all in SI units. Now this thing from here to here is the H and minus R. So this number is basically H minus R, and the unit is SI, which is meters. So now in kilometers, it's these three you can neglect. It's 1027 kilometers, or almost consistent with 1030 kilometers that you expected.
Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.